Hello, students. Today we are going to discuss some fundamentals of software engineering in this class, and we are continuing from our previous session, which is based on classical sequential, which was based on classical sequential software development lifecycle. We have learned built and fixed lifecycle model, waterfall model, V-shaped lifecycle model, interactive lifecycle model, incremental lifecycle model, evolutionary lifecycle model, and prototyping model. In today's class, we will discuss about Bohem's spiral lifecycle model, WinWin spiral lifecycle model, object-oriented lifecycle model, and prototyping and object-oriented lifecycle model. So let us start with the Bohem's spiral lifecycle model. In a spiral lifecycle model, uh, this is a clear-cut representation of. You can see it in this PPT. It is a clear-cut presentation of Bohem's spiral lifecycle model. The spiral lifecycle model combines elements of the waterfall lifecycle model along with an emphasis on the use of risk management techniques. So you can see here the in this phase dedicatedly this is dedicated to risk analysis. Okay, so Bohem proposed a model. This is spiral model in 1987, where each round of the spiral identify the sub-problem which has the highest risk associated with it and finds a solution for that problem. Its main feature is that it is primarily risk avoidance driven rather than document driven, code driven, or release driven. Okay, so this risk analysis phase makes it as a risk driven nature. Okay, now let us discuss about the working of spiral life cycle model. Each cycle of the spiral uses the same high level processes that are outlined, like determined objectives, alternatives, and constraints, evaluate alternatives, identify and resolve risks, develop, verify next level product, and plan next phases. So these are the four segments of this model proposed in this model. These segments are dedicatedly related to the compliance of the user instruction and compliance with the project charter. Within this framework, the task may resemble those of the waterfall lifecycle model, with the additional of specific risk management techniques are there. Review occurs as a project management checkpoint after each cycle is completed. So the radical dimension of the graph depicts the increasing total cost of the project, and the angular dimension depicts progress through steps. So you can see here in this illustration then that it is a like a spiral. Okay, and it shows the progress of the project development of project. It starts with the determination of objective, identification of objective, alternatives, and constraints, and then it every spiral comes in the second phase, that is evaluate alternatives, identify and resolve risk section. Then it will go under the development, verify the next level product, which is the actual development of the system of the software, and then the planning phase is there. Then the spiral moves again and again and again. Okay, the detailed steps, we can let us start with the detail of each step. Each cycle begins with identification of the objective. You can see here the identification of objectives. So each spiral begins with the identification of objective. So the spiral model begins with the identification of objective. This is one spiral, this is the second spiral, and this is the third spiral, and so on. So there are too many spirals. We can say there are four spirals in this illustration, and it starts with the identification of user requirements. So we can say that each cycle begins with the identification of the objectives of the portion of the project being elaborated on this cycle. The alternative means of implementing this portion of the product and the constraints imposed on the application of the alternatives. The second is the next step is the evaluate the alternative relative to the objectives and constraints. So risk analysis part is there. Risk analysis means evaluation and development of prototype. It is related to the development of prototype. You can see in the illustration, development after the risk analysis, development of prototype is there. After the risk analysis, again development of prototype 2 is there. After the risk analysis, development of prototype 3 is there, and after the risk analysis, final prototype, that is operational prototype, is there. So this is this phase is purely related to the evaluation of alternatives, identify and resolve risks in the project. So as an outcome of this evaluation, areas of uncertainties may be identified that are significant sources of project risk. If so, the next step would be to develop and follow a cost effective strategy for resolving the resources of risk. And this may include the use of prototyping, simulation, benchmarking, okay, and other risk resolution techniques. So you can see in the third phase, there are simulation, modeling, and benchmarking is there to resolve the risk identified in the previous section. The first risk to be resolved may be one that threaten the planned concept of the operation of the new system. So if the planning is wrong, risk due to the inappropriate planning to be resolved in the early phase. Okay, once the prototype or other risk resolution techniques is effective in mitigating that risk, the next step of developing the concept of operation can be taken, followed by the next cycle. And the second cycle proceeds to develop the software requirements and to perform requirements validation. Again, proceeded by planning, determination of objective, alternatives, and constant and risk analysis and mitigation. So you can see in the in this spiral model, this is for eliminating the overall risk from the software development. The third and fourth cycle focuses on further stages of development, as shown in the lower right quadrant of the of this illustration, and are preceded by planning through risk mitigation relevant to those stages of development. So you can see here in the first spiral, we are doing risk analysis and development of prototype. Then we check the prototype. Then concept of operation is formulated. Then we have plan for the next step. Then spiral moves towards, we are again identifying the objectives and alternatives and constraints. Then again we are doing risk analysis, we are performing risk analysis and developing the prototype 2. Then we are evaluating this before development. Then we are inquiring the software requirements, requirement validate, we are validating the requirements. Then we are planning for the development, then so on. So the coil is moving towards the development. At this point, all parties with a uh, great interest review the results of the previous cycle and commit to the plan for the next cycle. While each cycle does include a uh, development process, the software is actually developed for release until the final cycle. So this is all about the spiral cycle. Mainly, it is the spiral is divided. Every spiral, every coil is divided into four phases. Uh, the first phase is, you can say, the starting phase of every coil is determining objectives, alternatives, and constraints, and then after this, evaluate alternatives, identify, resolve, and resolve risk is the second phase. After identification of the risk and resolving of the risk, resolve risk means development of prototype. So after resolving the risk, you can see here the coil is entered in the actual development, and verify the next level product, and then the coil entered in the next planning phase for the next phase. And uh, the next phase starts with the uh, uh, first thing, that is objective, identify the objectives and alternatives and constraints. So this is all about the Bohem spiral model. It is a very refinery model, and it will provide the uh, pure refined system. Now we will discuss about the benefits of the spiral life cycle model. There are several major benefits of this model. First benefit is the primary advantage of a spiral model is that its range of options allow it to accommodate the best features of existing software process models, while its risk-driven approach helps it to avoid most of their difficulties. So we can say that a spiral model provides you several options to resolve risks and to purify, to refine your software system. The second benefit of a spiral model is, in appropriate situations, the spiral model becomes equivalent to one of the existing process models, and in other situations, it provides guidance on the best mix of existing approaches to be applied to a given project. And thirdly, the third advantage, you can say that the spiral model can be used with a spectrum of methodologies, whether they are specification oriented, or they are process oriented, or they are object oriented. So these are the important benefits of a spiral model. If there are various benefits of a spiral model, then some limitations are also there. What are the limitations? The limitation of the spiral life cycle model is that the life cycle steps needs further elaboration to ensure that participants in software development have a common understanding. If they are not having the common understanding, that then the model will not provide the desired results. Okay, so we had discussed about Bohem's spiral life cycle model. This model is proposed by Bohem in 1987, and it is a refinery model, you can say, because and it is a risk-driven model because it provides a quality software product. Okay, now come to the uh, next model, that is win-win spiral life cycle model. The win-win spiral process model is a model of a process based on theory W, which is a management theory, and approach based on making winners of all the system's key stakeholders as a necessary and sufficient condition for project success. So The original spiral model uses a cyclic approach to develop increasingly detailed elaboration of a software system's definition, uh, culminating in incremental release of the system's operational capability. So here you can see the win-win spiral model approach. The win-win spiral process explicitly emphasizes continuous collaboration, involvement of a software product's stakeholders in its early definition and development stages. So, there are major features of this. There are mainly two major features of this uh, model. The first feature is it provides an explicit set of goals for collaborative software definition and development. And secondly, it embeds the collaboration activities explicitly within a robust lifecycle process model, the spiral model. So the resulting process uses a theory W of win-win approach to coverage on a system's next level objectives, constants and alternatives. Okay, so how it works? It works in major two steps. It uses major two steps to accomplish this. First is identify the system's stakeholders and their win conditions, and the second is reconciling win conditions through negotiations to arrive at a mutually satisfaction set of objectives, constants, and alternatives for the next level. So you can see in the illustration there are seven steps of in a win-win spiral model. The first step you can see in the first step, that is identify next level stakeholders. So in this step, you identify the next level stakeholders. These are the people who you need to make happy after the current phase of development. The second stage is identify stakeholders win conditions. Identify stakeholders win conditions. And in this step, the stakeholders goals and concerns or objectives are documented. So uh, 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 in this stage we will identify the stakeholders win condition. The third step is reconcile win conditions, establish next level objectives, constants and alternatives. And in this step it is made sure that the win conditions are consistent and can begin planning for the next level. The fourth step is the evaluate product and process alternatives, resolve risk. In this step, the current project is examined carefully to consider alternatives and to resolve any risks that may have been found. And if they have not been found, but later cause problems, blame someone no longer on the project. The third step is the fifth step is define next level of product and process including partitions. And at this step the next level is further defined and many partitions the system and may partition the system into subsystems that can be developed in parallel cycles. And in the next and this is actually useful if a system can be broken into an easy part and a hard part, because you can delegate the hard part to someone else. So in the sixth step, validate product and process definitions. Most people don't like this step because of the evil uh, uh, connotations of step 6, especially when repeated, but unfortunately it is a necessary step. So validate product and process definition is an important step, that is sixth step. And the seventh step is review commitment. So in this final step, all the work is reviewed that is been done so far, and make sure that the product is still feasible and worthwhile. So this is all about the win-win spiral life cycle. You can make a spiral of having seven stages. In the Bohem's spiral model, we we have seen the four stages, four phases there, but in the win-win spiral life cycle model, we are having seven phases. Now come to the next level, next model, that is object oriented lifecycle model. It is again an important model. While not strictly a software lifecycle model, object oriented development employs an object oriented strategy, and object oriented software engineering is also geared up. The primary activities are uh, object oriented analysis is the primary activity of this object oriented lifecycle model. Object oriented designing activity is the primary activity of one of the primary activity of object oriented lifecycle model, and object oriented programming is the another and important primary activity of object oriented lifecycle model. Notice that much of the testing phases and certain aspects of other phases follow the traditional approaches. The primary difference between the object-oriented development and other development lifecycle is in the modeling of the system components. Other development life cycles operate on a separation of events and data, while the object oriented development encapsulates events with the specific data for which the event is valid. So, object oriented analysis develops an object oriented model for of the application domain, and object oriented design develops an object oriented model of the software system. Object oriented programming realizes the software design with an object oriented programming language that supports direct implementation of objects, classes, and inheritance. So, there are a wide variety of object oriented methodologies that have been proposed. Common to almost all of these methodologies are object identification, object organization, and object interfaces. Okay, identification means system objects and identification of system objects and their characteristics and events. Object organization means shows how objects are related via part of relationship, and object interfaces means shows how objects interact with other objects. So these activities tend to be overlapping and in general parallel. The useful division of a software project into phases remains intact with the use of object-oriented technique, which is shown in this illustration. You can see this thing in this illustration. It starts with the requirement analysis, then system specification, then designing, then planning, then implementation, and testing, maintenance. Okay, so this is the one phase, and this is the other phase. Designing, planning. After the planning, documentation is there. You can produce documentation to the planning documentation is there. Then so this is there is the mainly two parts, three parts. First is object identification. You have to identify system objects and their characteristics and events. And what this model suggests three things: object identification, object organization, and object interfaces. So first of all, you have to identify the objects and their characteristics and events. Secondly, you have to organize them and identify and establish the part of relationship. And third is, you can ensure how objects interact with other objects. Okay, so the requirement analysis stage strives to achieve an understanding of the client's application domain, the tasks that a software solution must address emerge in the course of requirement analysis. And the requirements analysis phase remains completely independent of an implementation technique that might be applied later. In the system specification phase, the uh, this is the system specification. In the system specification phase, the requirement definition describes what the software must product must do, but not how this goal is to be achieved. One point of diverse from conventional phase model arises because implementation with object-oriented programming is marked by the assembly of already existing components. The class library serves as a tool that extends beyond the scope of the individual project because classes provides by one project can increase productivity in subsequent projects. So, newly created classes must be tested for new general usability. If there is a chance that a component could be used in other projects as well, it must be included in the class library and documented accordingly. So, this also means that the new classes must be announced and made accessible to other programmers who might profit from it. And this places new requirement on the in-house communication structure. The actual software lifecycle occurs when new requirements arises in the company that initiate a new requirements analysis stage. So object oriented lifecycle model is a very important model, and there are several major advantages of this model. The first advantage is that design is no longer carried out independently of the later implementation, because during the design phase we must consider which component are available for the solution of the problem. Secondly, design and implementation become more closely associated. And thirdly, duration of the implementation phase is reduced. So, a new job title emerges, the class librarian, who is responsible for ensuring the efficient usability of the class library. Uh, that's why object-oriented lifecycle is very much important due to its various advantages. The object-oriented lifecycle model is very much important uh, in all the classical lifecycle models. Then come to the next next model, that is prototyping and object-oriented lifecycle model. In this model you can see you can understand the this model very easily through this illustration. The specification phase steadily created by prototypes, and each time there is a problem of modifying or enhancing existing prototypes. If the prototype were already implemented with object-oriented technology, then modifications and extensions are particularly easy to carry out. This is the purpose of this model. This is the combination of prototyping and object-oriented lifecycle model. So, as depicted in the figure, this allows an abbreviation of the specification phase, which is particularly important when proposed solution be repeatedly discussed with the client. And for such an approach, it is not important whether the prototype serves specification purposes or whether it is to incrementally developed to the final product. If no prototyping tools are available, object oriented programming can serve as a subroutine tool for modeling user interfaces. Okay, so this particularly applies if an extensive class library is available for user interface element. So this is the illustration, general illustration of uh, prototyping and object-oriented lifecycle model. It is a it provides a clear-cut understanding. This illustration provides a clear-cut understanding about this model. This is a very important model, and we can say that it is the combination of or integration of the final classes and their user interface classes creates a prototype that can be tested and validated. And this places the new requirements of the user interface and or the functionality, so that the cycle begins. And lastly, we can achieve the after testing and validation, we can achieve the final product. This is providing the prototyping approach, and it provides the function oriented design, user interface design, and other designing practices along with testing and validation. So when we integrated all the classes and all the functions of software, then we can make a prototype of the functional model, then test and validate. After the test and validate, you can deliver the product to the client. Okay, so this is prototyping and object oriented lifecycle model. Now we will make a comparison and suitability of software lifecycle models. We have learned various models, software development lifecycle models. We have learned their advantages and disadvantages or limitations of each and every model. So now uh, we have to compare uh, all the models with each other. A comparison of the software lifecycle model is the best accomplished by using the waterfall model as the basis for comparison. And this is true for two reasons. First is the waterfall model is the most familiar to the majority of developers. And second, almost all other models were created to improve upon it. So, waterfall lifecycle is the basic model. Uh, Industry people like the basic model, and secondly, all models we have studied have generated from the or developed from the basic model. This basic model, which basic model? uh, 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 the waterfall life cycle model. Okay. Besides comparison, suitability of all the important software lifecycle model is also uh, we should discuss also. Uh, like first, we will discuss about the waterfall. When we are discussing about the waterfall life cycle model, uh, uh, the waterfall life cycle model is the most straightforward and views software development as a series of processes that are expected to be carried out only once for the project, and these are carried out in the proper order, and the results documented for input to subsequent processes. Because of the emphasis on thoroughness, documentation, and control, waterfall model is the best suited for large projects where requirements are known and stable and understood. And its weakness includes inflexibility for change, length of time before anything usable by the customer to produced, and the implied requirement to complete every process correctly the time first time. Then we will discuss about the incremental life cycle model. uh, when we discuss about the incremental life cycle model, this model is similar to the waterfall in many respects, but it differs in that it produces some tangible results to the customer sooner. The initial processes of system requirements and feasibility, software requirements, and general design are done in sequence once for the overall project. Partitioning into increments then occurs where a number of different development efforts beginning with detailed design are identified, and these increments can be planned as sequential or parallel efforts depending upon the project characteristics and project constants. For the same reason, as the waterfall model, incremental lifecycle model is suitable for large projects with requirements that are known, stable, and understood. Okay, so given these project characteristics, incremental lifecycle model is the best choice when every release of some parts of the software is beneficial, or when earlier release of the entire system can be accomplished through multiple teams working in parallel on or on different increments, and when requirements are known and understood but but may not be stable, the incremental model is a logical choice because later releases can incorporate changes that surface during the earlier development efforts. When we are talking about evolutionary life cycle model, the evolutionary life cycle model applies in sequential aspects of the waterfall model and partitioning of the project borrowed from the incremental mode, but adds the evolution or the discovery of requirements. So evolutionary life cycle model is preferable life cycle model when requirements are not fully known, but a subset of the requirements is known, stable, and understood. Uh, Benefits of what There are some benefits of evolutionary life cycle, which includes the early delivery of some functions and the early testing of some assumptions before the entire system is built around them. And the major weakness of this model is related to the inability to plan in detail at the outset of the project. Uh, when we discuss about the spiral life cycle model, which is a again a wonderful life cycle model, and which is provide you which is available in a risk driven nature. At the first glance, the spiral model appears to be the most radical departure from the waterfall model, and this is because of the way it is diagrammed. So, if the processes within the four cycle of the spiral model were drawn in a cascading fashion like uh, the waterfall, the standard processes from requirements and feasibility to operations and maintenance would fall in the same order and would be done in sequence, just as in the waterfall model. The difference would be in the insertion of the non-standard processes of determining objects, alternatives, and constants, evaluating alternatives and constants, evaluating alternatives, identifying and resolving risk, and planning each cycle. So these are four stages of four, you can say four phases of spiral life cycle model. The efficiency achieved on the standard process will be greatest on projects where several risks have been identified in the second phase and expected to surface during the course of the project. So, risk driven nature is the second advantage of uh, the mm, the spiral life cycle, and controlling over the development process and systematic planning. These are the other advantages of waterfall, other advantages of spiral life cycle. Okay, this is all about today's lecture. Now we can do the self assessment through multiple choice questions. There are some multiple choice questions related to your previous knowledge. Uh, the first question is data centered methodologies utilizes dash as the core of the system concept. The data model is the right answer of this question, because data centered methodologies are the utilizes the data model as the core part of the system concept. In the second question, dash is a linear sequential software development process model that emphasis on extremely short development cycle using a component-based construction approach. Uh, the four from the four options, first option is spiral model, second is waterfall model, third is iterative enhancement model, and fourth is RAD, rapid application development model. So the answer is rapid application development model is the linear sequential software development process model that emphasizes an extremely short development cycle. When we are looking for the short uh, development in a short time, then the short development cycle is known as rapid application development model. RAD stands for what? Rapid application development. That is B is the right answer. Then which one of the following model is not suitable for accommodating any changes? Which model provides and not provide you the freedom for change? Build and fix? No. Prototyping model? No. RAD model? No. Waterfall model? Yes. So the right answer is D. There is no provision to go back in the previous stage when due to some requirement changes in the requirement or due to some error. There is no provision in waterfall model. So right answer is D. Which one of the following is not a phase of prototyping model? Which one is not the phase of prototyping model? First is quick design, second is coding, third is prototype refinement, and fourth is engineer product. So coding is not the part of prototyping because prototyping is the only the model. Prototyping model provides the functional model only. It will not provide you the final model. Okay, so designing is there, refinement is there, engineering product is there, but coding is not there. Which of the following statement regarding build and fix model is wrong? No room for structure design, code soon becomes unflexible and unchargeable, maintenance is practically not possible, and it scales up well to large projects because build and fix is suitable for small projects. So it scales up well to large project is the uh, right answer. RAD model has two phases, three phases, five phases, or six phases. Five phases are there in the RAD model, as you know. The what is the major drawbacks of using RAD model? The expected answers are highly specified and skills developers or designers are required. Secondly, increases reusability of components. Thirdly, increases customers or clients feedback. And fourthly, increases usability of component. Highly specified and skilled developers or designers are required. So because RAD model, we have a task to develop application in a very short time. Then we have to increase reusability of components, and highly we require highly specialized and skilled developers designers for accomplish the task in the given time limit. In the next question, SDLC stands for what? SDLC, Software Development Lifecycle. So the answer is A. Which model can be selected if user is involved in all the phases of SDLC? The waterfall, prototyping, RAD, or both prototyping model and RAD model? The answer is RAD model. Okay, so which model can be selected if a user involved in all the phases? In the RAD model, user is involved in all phases. Apart from this model, there is no other model where active involvement of a user is there in all phases. Okay, so this is all about today's class. We have learned spiral model, Bohem's spiral model, WinWin model, and other two models also, and we have assessed we have done the self assessment. uh, if you have any query, then you can consult these classes. These are these books. These are the reference books. You can consult and find out your uh, solution to your problem. Thank you.